switch to our second and final speaker for this session. Professor Hugo Spiers is joining us from UCL Institute of Behavioral Neuroscience, and he will be teaching us about the neural and cognitive and cultural foundation on navigation ability. Something I know very little of, so I'm very curious, as most of you, I'm sure. So Hugo, if you want to start sharing your screen, we can jump right into it.
Great. Okay.
That looks great. Thank you very much.
You can see my screen. Great. Oh, thank you so much for organizing this. It's a fantastic conference. So yeah, as was mentioned, I'm going to really ask the question of what determines navigation ability? Why are some of these people in this group potentially better than others at navigating? Is it their brain structure? Is it the neural coding they have? Is their age and gender important? And indeed, is the culture that they've grown up in or exist in affecting how well they can navigate? In terms of brain structure, a key study 20 years ago is the discovery that London taxi drivers, here's a photograph of one, actually have a larger posterior hippocampus. And this is interesting because they spend 4 years memorizing 58,000 streets that they have to navigate without using digital aids to use their license. And that's been replicated. We compared bus drivers to taxi drivers and found, bus drivers are boring, taxi drivers are very large hippocampus. And indeed, Ellen McGuire has shown that their hippocampus changes longitudinally with the training they have. But for the rest of us, the mere mortals amongst us like me, there's not a huge, some studies have shown some relationship between brain structure and navigation ability, but others more recently have suggested also that it's not clear that there's a link for healthy younger individuals. So it's a bit of a mixed picture currently between brain structure and navigation ability, and it's something we need to investigate. And indeed, my group are currently actively studying taxi drivers and non-taxi drivers to make that leap. But what about neural coding? Why might one of your friends be so good at navigating and another one not very good? In a study we ran 5 years ago, we had people navigate around a very simple environment, a courtyard, and they had to think about different directions to goals, and inside that, we could decode which way they were facing and where their goal was from the entorhinal activity using a representational similarity analysis of the fMRI signal. But what's important here for the story I'm telling is that the precision and the reliability of that direction signal in the entorhinal region could predict to some degree how accurate our participants were. It's a very small sample, but it mirrors evidence from Christian Dohler and colleagues showing that the grid coherence signal they could detect in their fMRI analysis, the stronger someone's directional coherence in their entorhinal cortex, the better their spatial memory. So there's very preliminary evidence really over a few studies, but it suggests that maybe the stability of the neural code for direction might be one of the reasons why some people are better navigators. But I'm going to spend the rest of the talk now looking at the sort of more the questions about differences between people in terms of demographics and the culture as to why those might play a role. And in doing so, I'm going to introduce a study we started 4 years ago. In 2016, we released See a Request, an app for mobile phones and tablet devices that anyone could download from the App Store and Google Play. And it was in 17 different languages, so it really was aiming to spread wide. One of the main reasons we developed this was again from the previous talk by Christos, that it'd be very useful to have some monitoring tools for spatial navigation problems in Alzheimer's dementia. It's a key early symptom, and the aim of this was to try and build something that would be useful. So in the game, the main part of it, you're playing a little boat and you're trying to navigate it around through a virtual environment to get to checkpoints. And here's two schematic examples of environments that we put down, like top bird's eye views. But I'll now show you level 17 of it. We have 75 of these levels in the game. And here's two people playing these different levels, and you can see they're passing through checkpoints. There's various landmarks, but what key thing here is that we're tracking their position in the game, and we can tell how accurate every moment is in terms of their navigation. We can score everyone that plays this game on their ability to navigate through these environments. Fortunately for us, it was funded by Deutsche Telekom, T-Mobile. We could reach out and get many people, and we have 3.9 million people's data now playing this game. And the person I'm going to introduce here, Antoine Coutreau, who's a French scientist who is the postdoc who began the work on this and now runs his lab looking at various other things, including this, has really been going through this data in great detail. We published 3 papers in the last few years, and we have a preprint I'm going to spend time talking about today. But really, for the purposes of this, you can downsample 3.9 million people substantially to just 150,000 to kind of reveal the pattern in the heat map of a given level. But if we downsample that to just 9 people, you can see someone in the bottom right here is absolutely appalling. They're going all around, just never really getting to the targets. Whereas the person at the top here is just phenomenally good. I just know exactly where to go without error. Why? What could explain these patterns of variation? The biggest explanatory variable, unfortunately for many of us, is age. There's just a linear decline across the world population in terms of age. From the earliest stage, it's not like you have to wait till later in life, it just declines. We see a consistent male advantage across participants around the world. When we fit linear models to try and explain why might populations in some countries be navigating better than others, we start to reveal some explanatory features. So what we found, and we published 2 years ago, was that actually on the y-axis here is the conditional modes rank from a linear model. So this is just in a rankings table from a very carefully done analysis accounting for other demographic features. So you can adjust for features like age and gender. How well different countries do. So Finland tops the league for the best navigators in the world. And we were trying to explain why might they be doing so well. And it seems like the gross domestic product of a country has a strong, powerful feature into explaining why some groups of people might navigate better than others. More wealth, more healthcare, all the things that are associated with GDP seem to play into giving people better navigation skill. So hopefully this might change with more equality around the world in terms of access to these things. We should also note that this isn't linked to just raw video game skill. You don't get this correlation if you're just good at video games. This is specifically to do with navigation ability. And so the other key thing we wanted to know was, why are we seeing this male advantage? And the male difference between men and women is huge in some countries and tiny in others. Why? Why is there a male advantage more in some countries? What we found quite strikingly is if you take the World Economic Health Forum's gender gap index of how unequal each country is, you can predict to some degree the rankings for why the difference between men and women. So Norway and Finland, there is almost no difference between men and women in their navigation ability, and they have the least gender inequality in the country. So hopefully this chart may change if we can move to more equal societies. This is a strong driver for any studies looking at sex differences and things in cognitive behavior, is that it may well depend on the country you're growing up in, the culture that people are raised in terms of what we might impact on that. And we also should note en route through this talk that we've also looked, Gillian Coughlin in Michael Hornberger's group. Michael's the co-lead on SeaRequest, and his team study dementia in the University of East Anglia has shown clearly that there's a negative impact of the genetic risk for Alzheimer's. So our particular wayfinding measure is sensitive to. So these are people who are perfectly healthy, but they are at significant risk of developing Alzheimer's. And indeed, they hug the edges of environments as they navigate more than people who are not at risk. But we hope this might turn out with more research in the future to tell us more about aiding Alzheimer's research. The last question I want to address in this short talk today is, how does the environment you grow up in impact your navigation ability? We've seen how GDP and gender inequality can, but what about if you grew up in a city or in a rural environment? There are big differences in what you experience growing up. So is there an advantage to one of these? And we found there is a difference. So what I'm going to show now is on the y-axis in a moment is navigation ability. So high on this axis is good navigators and low is bad. And I'm going to plot that over age. So you'll see the horrible dramatic loss with performance with age. We'll show you the male advantage where men are doing better, but I'll also now separate this so we can see dramatic loss with age and the male advantage that men are doing better. But the green line and the gray line show you the advantage you have of growing up outside a city if you're navigating. So it's not as big as the gender divide, but what we can see is that a woman who's grown up outside a city in her 70s is equivalent to a 60-year-old who grew up inside a city. So there's a real genuine difference here in terms of the impact of this. But not all countries show this strong effect. This is the world average. And so some countries have a very big effect and others a much smaller effect. For example, there's not much effect in Greece, where Christos is, I imagine, sitting. But there is in the USA and in Argentina, there's a very strong effect. Why? Well, we realized that cities vary a fair bit around the world in one key feature. There are many features, but one key analytical feature you can see is how gritty they are. So Chicago in the bottom right here, its streets are highly organized. they're really aligned northwest, east, south, and you can measure with Shannon's entropy how disorganized or organized cities are. So what we did, I'm going to show you on the y-axis of the graph, is countries of the world plotted by their street network entropy of the top 10 cities extracted by Antoine going through OpenStreetMap. On the y-axis, the negative impact of growing up in cities. And you can see there's a negative correlation between these two variables. So growing up in a city with high street network entropy means less negative impact of cities on your ability. So people growing up in Argentina are having a worse impact of their street networks on their navigation, it seems. So it seems that might be, that gives us evidence that it's the structure of the environment that may be playing a role. We decided to go a bit deeper than that. And in my last slide, I'm now going to show, we'd look back at the game levels. So some of the levels you saw in my movie earlier are quite city-like in their structure. Others are much more convoluted and have a high entropy. And so what we can do is plot those along this x-axis here of how the different points on this graph relate to our performance in different game levels against the negative impact of cities. So what we see is that, yeah, as we'd expected, growing up in cities generally has a negative impact on navigation ability in our complex levels. But actually, when you go down to more simple, more grid-like levels, there's even an advantage potentially of having grown up, say, in New York City or Chicago on your ability to find your way. So it's not all a bad thing growing up in gritty cities. Our data overall, the take-home message in this talk is really that humans appear to adapt their navigation ability depending on their environment. And we're looking at this in lots of nation states, 38 countries across different languages and cultures, and large samples. I've also talked at the beginning of this talk about the need to understand greater the link between our neural representations and brain structure and navigation ability. We're beginning to see effects. And I mentioned there's a clear impact of age and indeed gender, but the gender impact is strongly linked to inequality. It's not, it's almost negligible when you account for that. Finally, I'd just like to acknowledge all the people that provided key input to this research I'm talking about, particularly Antoine Coutreau, who did all the painstaking work analyzing the data with us, and Michael Hornberger, who's my key lead on SeaRequest, and Ed Manley, who's the geospatial analyst who's put a lot of time into the work, and also the funders who've made it all possible to actually do this work. So I'm happy to take questions now from anyone listening. Thank you.
Thank you very much. Amazing talk and great wealth of data. I see already questions coming in, so I'm going to have to keep mine for afterwards. Alan Andred, he's asking, what about educational level? What do you suppose it has an impact?
That's a fantastic question. So I forgot to mention as I went through that yes, we modeled, I didn't show on the graphs, we also model in their education level, because you might worry that people who grew up in cities have less education. And indeed, we were able to account for that as a covariant. We find that we still see a negative relationship with the entropy, even when we account for education. So it's not purely driven by education. Education has a pretty similar level to that home environment effect size on wayfinding. So it certainly does. We knew it's a key variable if you're going to be looking at diagnostics for something like dementia. So yeah, and it's something we're indeed writing up. There's some very interesting analysis you can do with education. So you can look at where countries they changed the education level. So in England, it changed 1 year.
Right.
And that we can see has interesting effects going back through the data, but we'll wait to submit that for preprint in the next years. I can see other questions coming in.
Yes, exactly. Avital is asking, thanks for the great talk, first of all, and wondering if you have any access to subject attention levels.
Oh, that's
this kind of psychological trait may impact the navigation abilities.
Oh, that would be lovely. So we don't have that. That's exactly the kind of thing where, having now done this large scale study, we hope to release a version of this application for other researchers to use alongside ourselves, where we can ask lots of questions very carefully about traits, levels of things like anxiety is another question to be interested to look at.
Absolutely.
We don't currently have that, but it's a really good question. But we don't have a measure in our current game for attention levels. And indeed, you can see people, if you look at performance, some people just sort of wandering off. And I would love to look at what's happening in those participants and who are they and can you predict that? But we haven't made it that far yet with the data. It's with 3.9 million quite large.
Yeah. Alan has a follow-up question, is wondering whether the difference in living in the countryside until 5 years old or 10 years old, like when should you move out
Yeah.
of the countryside?
Right. So that's a great. We don't know the answer to these questions, but these are the kind of questions that will be extremely well answered, I think, through using birth cohorts, where you have the postcode that somebody lived in from their birth to the point you test them, to see if you can model that. But we don't know yet whether the general upshot of it is it looks like if someone says they generally grew up inside a city, it overall has a negative impact on most complex environments. But if you get a bit of other things like you grow up outside cities in the suburb, then it's better. It's people are performing better.
Yeah.
There's
I was trying to do the math in my head. I'm a female, but I grew up in the countryside.
yeah, exactly. We can pinpoint you. We'll have thousands of people who we can compare you to. So you have more questions, yeah.
Exactly. Ameya Menon is asking, for the video game, did you see any improvement in navigation ability over time over varying maps?
Oh, great. So we have looked at that. After this meeting, I'm going to have a meeting to discuss how we can move forward to pre-printing a paper looking at that, where if I remember correctly, we see people who are not very good navigators benefiting more from repeated experience in it, which is nice to see. It's not just everybody benefits from retrying. A nice feature of the game was that there was, you really had to work hard to get 3 stars. So people repeatedly played levels, and we'll be able to take apart that in a lot more detail as we move forward. I should say as well, raises the point, if anybody is interested, they can get in touch with me to potentially use the app, a research version of it for a study they want to run, or to analyze the massive data, which we hope to make available very soon.
Exactly. This is actually the last question that just came in from Denise Enriquez, and it's also my question. What can we do as researchers to get our hands on the app?
Yeah, just literally contact me through Twitter or email. If you just Google me, you'll find me available. We'll be delighted to help other teams. We are collaborating with lots of different people with See Here Request, but we'd be happy to collaborate with more. And the large 3.9 million data set that will be made available soon once we get that recent preprint published. That's the aim.
That is amazing. I'm sure you will be floated with messages and requests now, and we will all keep an eye on that preprint. I believe I did share the link, but yes, I did. But yeah, we will all keep our eyes on you. I want to thank you very much, and Christos as well, if it's still around, for the two